In this lecture, we're going to solve equations by factoring, which is a review of what we've done before, and then we're going to focus on quadratic functions, and we're going to introduce another method of solving, which is called completing the square. And then in the next lecture, we'll focus on another method of solving quadratic equations, where we actually will have an equation, a formula that we can use called the quadratic formula. So let's begin by reviewing the technique that we've already seen before, and let's try to solve this problem here. So we have 3x squared equals 75. So the method that we've been using by factoring is to use the property of 0. So if you can first bring this 75x over, right? So subtract it over, and we'd have 3x squared minus 75x is equal to 0. And now, if we factor the left-hand side into a product of factors, then we can use the property of 0 to say that, well, we're guaranteeing that one of those factors has to be 0, and so we can figure out what the potential solutions are. So what can we factor out of this? Well, both of these terms have a common factor of 3, but they also have a common factor of x. So if I factor out 3x out of this first term, 3x squared, we'd be left with an x. If we factor out 3x out of 75x, negative 75x, sorry, we'd have minus 25, and that would be it, right? Because 3x times this would be minus 75x. Okay, so this is equal to 0. And now the property of 0 would say that 3x is 0, or x minus 25 is 0. You could all, and this would say x is 0, and then adding 25 over is this. So we have x is 0, or x is 25, and those would be our two solutions. For our next one, let's try to do the same exact thing. So we have 4x cubed minus 10x squared. Let's bring this 6x over. And you know what? Let's factor out as much as we can out of each of these. So it's a cubic, but we have a common factor of the coefficients of 2. And it looks like we could also factor out an x. So what would we be left with here? We'd be left with a 2 and then x squared. Here we'd be left with minus 5 and an x, and then we'd be left with minus 3. And let's just double check that. So 4x cubed minus 10x squared, and then minus 6x. So that looks good. And then we'll have to factor the remaining portion of this. So we know that since the leading coefficient is a 2, we're going to have a 2x and an x. And 3 only has a factors of 3 and 1. And if I'm getting a negative, then one of those is going to be negative, and I need to get the sum as negative 5. So it looks like we would do negative 3 to give us negative 6x, and then plus 1 will get us back to minus 5x. And so let's check that. So 2x squared minus 6x plus x will give us minus 5x, and then minus 3. So that looks like the correct factorization. And property of 0 would say that 2x is 0, or 2x plus 1 is 0, or x minus 3 is 0. Okay, so solving this one, we have x is 0, subtract, we have 2x equals 1, divide by 2, we have x is a half, or adding 3 over here, we have x is 3. So our solutions are those 3 right there. So x is 0, or x is a half, or x is 3. Oops. Okay, so now we have a cubic. Let's subtract terms over. So we have 6x cubed minus 7x squared minus 3x. So it's just subtracting these two over to this side equals 0. And now let's factor. So we have 6, 7, and 3. So there's actually nothing in common that we could factor out other than 1. That wouldn't really help us among those coefficients. But we could factor out an x, and we'd be left with 6x squared. Factor out an x out of that, we have minus 7x. Factor an x out of that, we have minus 3. Now we need to factor this, so we could, here we're going to have a lot more options, so you would have to do some guessing and checking here. At least knowing that the product of the last term is a negative 3, then we know that one of them is going to be either minus 3 and plus 1 or minus 1 and plus 3. And 6x, we have a couple of possibilities, right? We could have 6x or an x, or we could have 2x and 3x, but a factorization that should work is to make this minus 3 and plus 1. So that would be 6x squared and then minus 9x plus 2x to give us minus 7x and then minus 3. So this looks correct. And now x is 0, or this factor is 0, or this factor is 0. So this would, subtracting over, we have 3x equals minus 1, divide by 3. So x is minus minus a third. Over here, add this. 2x is 3 divided by 2. We have x is 3 halves. So we have x is 0, or x is negative 1/3, or x is 3 halves. You know what, I just noticed a small little error up here. This should have been minus 1, minus a half, minus a half. So continuing on. Okay, what can we factor out of here? So we would have, well, first let's isolate. So 15x squared plus 14x and then minus 8 equals 0. And what can we factor out? Well, these two don't have any common factors other than 1, so the best we could just do is try to factor, just explicitly the way that it is. So 5x, 3x, minus 2, and plus 4. So let's see if that works. So we'd have 15x squared, so that's good, and the minus 8 is good, but then we have 20x minus 6x will give us the 14x, so that looks good. So that means we have 5x minus 2 equals 0, or 3x plus 4 equals 0. So adding the 2 over, we have 5x equals 2, divided by 5, we have x equals 2 over 5. And over here we would have, subtracting, we have 3x equals minus 4, divided by 3, we have x is equal to minus 4/3. Okay, now the next example, let's bring this 36 over. So we have x to the 4th minus 13x squared and then plus 36 equals 0. So this is a quartic, which would be in general pretty difficult to factor. However, the middle term is a quadratic. So a possibility would be that the first two are x, x squared to give us the x to the 4th. We need the product of the last two to give us positive 36. Since we're getting a negative in the middle term, it looks like we're going to have a minus and a minus. And can you think of any two factors of 36 whose sum would give us that 13? Well, that seems like it would be 9 and 4, right? So 9 and 4. And so that should work. So that would be minus 4x squared minus 9x squared would give us the minus 13x squared and then the plus 36. Okay, so that looks good. And then these two actually can be factored a little bit more, right? There's a missing middle term. It's a difference of squares. So this would be plus 3, x minus 3. This will be x plus 2, x minus 2. And then now property of 0 would say that x plus 3 is 0, x minus 3 is 0, x plus 2 is 0, x minus 2 is 0. And then that would give us the solutions of x is minus 3, x is 3, x is minus 2, x is 2. All right. Moving to this example, let's bring these terms over. So we'll have x cubed plus 7x squared minus 4x minus 28 equals 0. Now, factoring cubics can also in general be a little bit complicated unless, say, it's a difference of cubes or a sum of cubes, but the method that we've been using that works once in a while is to do factor by grouping. So let's try and see if we can get that to work. It looks like it might be reasonable because these two have a common factor of 4, and that'll give us a 7, so it looks like that might actually work. So let's do factor by grouping, meaning let's factor that binomial and that binomial separately as much as we can. So these two have a common factor of x squared, so we can factor that out and get x plus 7. These two have a common factor of minus 4, and that'll give us x plus 7, so this is very good. Right? So now these two terms have this x plus 7, so we can factor that out. And then if I factor out x plus 7 out of these two, then I'm left with the x squared. Factor out x plus 7 among this whole term, we'll have a minus 4. And that means we'll have x plus 7, and then this factors as x plus 2, x minus 2 equals 0. And then now we'll be able to write the roots. We will be able to use the property 0 to say that this is 0, or x plus 2 is 0, or x minus 2 is 0, which would tell us that x is negative 7, or x is negative 2, or x is 2. So now we're going to solve some quadratic equations using another technique called completing the square. So far we've been using the factoring technique. That's very useful, and we're going to see another method as well. So the first steps are to bring the constant term to one side of the equation. Okay, so on the left side you'll have your squared term and your linear term, and then on the right side you'll have your constant term. Then what you have to do is you have to divide both sides of the equation by a. In this first example here, a is 1, so this step you might not, well, if a is 1, then you just can skip that step, right? And then here is sort of the step that makes everything really work. You're going to add this term to both sides of the equation, and what you're actually doing here is, after you do step 2, you're going to take whatever the coefficient of the linear term is, and you're going to take half of it, you're going to divide by 2, then you're going to square it, and then you're going to add that number to both sides of the equation. And the reason for that, as you'll see when we solve these problems, is that the left-hand side of what you have after step 3 is that you'll be able to factor that. It'll be the square of a binomial. And because it's the square of a binomial, we can finish the solution by taking the square root of both sides. So this is sort of like the weird step where you have to figure out what you have to add to both sides. But after that, the rest of it is sort of a little bit more standard. So let's begin by solving this one right here. So first, we will bring the constant term to the right side. So we're going to add that 15 over here. Okay, and so now we have a is 1, b is 2, and that c is 15. Okay, so a is 1, dividing both sides by a, it's already done. All right, and so now we will add b over 2a squared. So what is that? That's 2 over 2 times 1 squared. So that's 2 over 2 is 1, so that's 1 squared, so that's just a 1. So we're going to add that to both sides of the equation. So we have x squared plus 2x plus 1 equals 15 plus 1. And now this right-hand side is the square of x plus 1. Right? This should factor, and it does, x plus 1, x plus 1. So this is what we were talking about. The left-hand side is a square of a binomial. So that's the goal of the next step, is just to factor it. But it's going to be very quick. And then this side is 16. And then now we can finish the solution by taking the square root of both sides. So you see, if I take the square root of both sides, then what do you get? You will end up with the absolute value of what's under here. So you'll actually can say, you can skip the step and just say, yes, it is the absolute value, but it might actually be faster for you to just say that it's plus or minus the square root of this over here. Okay. If you skip that step, you would write that this is the absolute value of x plus 1, but we know that you can get rid of the absolute value by replacing it with that plus and minus. Okay, and then now subtracting this, we will subtract it over. You have minus 1 plus or minus square root of 16. So that's actually the two solutions right there. So you have negative 1 plus root 16, negative 1 minus root 16, and those are your solutions. And this is how completing the square can work, and that's very helpful because now if you think about it, that's what the factors would actually be. So I couldn't really use the previous method because it's unlikely that you would have guessed that, because the method of guessing by factoring and whatnot, we were always looking at things being sort of whole numbers. And now, well, here's examples where you're definitely getting roots, right? But you could simplify this, right? And it probably would be better to fully simplify that a little bit more instead of boxing it, I guess, right? Because we know that root 16 is 4, right? So what is that? So this is plus or minus 4. So we have x plus 1 is equal to 4, or x plus 1 is equal to minus 4. So what do we get here? So this is x equals 4 minus 1, so that'll be a 3, or x is equal to minus 4 minus 1, so that's x is minus 5. Okay, so here's our two solutions, which would have just been the simplified versions of what I wrote before, but that's it. Okay, now continuing, let's do the same thing here. So what do we have to do first? Well, we have to first bring the constant term over, so we have 2x squared plus 8x equals 24. And so here's A, here's B, and here's C. Okay, so the next step says to divide both sides by A. Since this is not 1, we have to do that step. So dividing both sides by A, we will 2x squared plus 8x equals 24. Divide by 2, divide by 2. This gives us x squared plus 4x is equal to 12. And then now, what are we going to do? We will add b over 2a squared to both sides of the equation. So let's just simplify that. B was 8. So this is 8 over 2 times 2 squared. So this is 8 over 4. So that's 2 squared, which is 4. Okay, so we'll add 4 to both sides of the equation. And look at what we have here. This factors as x plus 2 quantity squared, and this is 16. And now taking square roots, x plus 2 squared, this will give us x plus 2 is plus or minus the square root of 16, which is plus or minus 4. And so now we have x plus 2 is equal to 4, and x plus 2 is equal to minus 4. So x is equal to 2, or x is equal to, subtracting, we'll have minus 6. Okay, so let's solve this one. First, we have to bring the 12 over. So we will have x squared plus x equals 12. So a is 1, b is 1, and c is 12. So we divide both sides by a, and here it is. So then we were going to add b over 2a squared to both sides, right? Okay, so what is this? So 1 over 2 times 1 squared, so this is 1/2 squared, so that's 1/4, so we add fourth to both sides, so we have x squared plus x plus a fourth equals 12 plus a fourth, and we could write that as 48 over 4 plus a fourth, which is 49 over 4. And the left-hand side, we can factor that now as x plus a half squared, right? If you FOILed that out, you would get x squared plus a half x plus a half x, which would give us x, plus a fourth, and then this is equal to 49 over 4. And now we take the square root of both sides, and we will have x plus a half equals plus or minus the square root of 49 over 4, which is plus or minus the square root of 49 over the square root of 4, which is plus or minus 7 over 2. And so we have x is equal to plus or minus 7 over 2 minus a half. So subtracting a half over here. And so then we have plus or minus, well, you know what, let me write those separately actually. So then what do we have? We have x is 7 over 2 minus a half, which is 6 over 2, so that's 3, or x is 7 or minus 7 over 2 minus a half, which is minus 8 over 2, which should be minus 4. And those are our two solutions. Okay, so continuing on, our next problem, let's first get into the sort of standard form. So then we'll have x, subtract the 4x over here, and then we have minus 1. So a is 1, b is minus 4, and c is this minus 1 here. So then we're going to add, well, we would divide both sides by a, but that's 1 in this situation, so we are going to add b over 2a squared. So that would be minus 4 over 2 times 1 squared. So this is minus 2 squared. So that's a 4. So we're going to add 4 to both sides. So we have x squared minus 4 plus 4 equals negative 1 plus 4, which is positive 3. And this factors as x minus 2, right, which is right here under the square. And you can FOIL it out to check, but this is equal to 3. So taking square roots, we have x minus 2 equals plus or minus the square root of 3. So then adding that over, we have x as 2 plus or minus root 3. And those are our two solutions. And finally, we have this last one here. So we have x squared plus 2x, and bringing this 4 over, we have positive 4. So a is 1. So dividing both sides by a, we're done with that. B is 2. C is 4. We will add b over 2a squared, right? b over 2a squared, so that's 2 over 2, which is 1 squared, which is just 1. So then we're going to add 1 to both sides. So this side will be x plus 1 quantity squared, and this is a 5. Taking square roots, we have x plus 1 equals plus or minus root 5. So that means x is minus 1 plus or minus root 5.